Hello students, can you see now? Okay. So can you see? I think it should be proper now. There was a network issue. Okay. So in that case, we are going to start with a new concept, that is chlorine. We are going to start with the chlorine, a new concept. Now when I am talking about chlorine, in elemental form it will be present as Cl2, diatomic form. That's what we have discussed with respect to halogens, which will be in the diatomic form at room temperature on its elemental form. So that's where we have the chlorine, which will be present as a gas. Chlorine will be present as a gas at room temperature. So which will be a diatomic molecule. Now when I am talking about chlorine molecule, its name is due to its color, which is yellowish green color. Chloros means yellowish green color. Fine. So that's where we have the chlorine as a gas. Now when I am talking about chlorine water, so when I am talking about chlorine water, that means liquid form. Like ammonia solution is there, na? Same way. So chlorine water if I have, so naturally it will not be 100% chlorine. So therefore it can be in a liquid form. So that's where we have the chlorine water. So this chlorine water, which will be in the beginning, when it will be fresh, they will be yellow color. They will be yellowish color. But slowly they will lose that color. Slowly chlorine water is going to lose that color. So that is because when I am talking about chlorine water, slowly they will get converted into, whatever chlorine is there, it will get converted into HCl plus HOC. It will get converted into HCl plus HOC. Fine. Now further, whatever HOCl is there, hypochlorous acid, whatever HOCl is there, it will be converted into HCl plus nascent oxygen. It will get converted into HCl and nascent oxygen. Fine? Whether I am clear? So that's where, due to the conversion of chlorine into HCl and HOCl, and if you keep it for a long time, that HOCl can be converted into HCl and nascent oxygen. So due to that, one thing here is, I have got two questions on same concept. One is, chlorine water will be losing its yellowish color. Give reason. That is due to the conversion of chlorine water into HCl and HOCl. So next question. Give reason for the oxidizing character of the chlorine. Give reason for the oxidizing character of the chlorine. So that's where, due to the formation of nascent oxygen, it can act as an oxidizing agent. Further, it can be acting as a decolorizing agent. So therefore, this can be the answer. Decolorizing agent. Give reason for the decolorizing property of the chlorine water or chlorine. Then the answer should be this one, where there will be liberation of nascent oxygen. So this nascent oxygen can react with the coloring molecules and which will become colorless. So that's where we have the reaction. Got my point? So this one concept, two questions can be answered by using this one concept. One is, why chlorine water, after some time it will lose its greenish yellow color. Then you should tell that is because of the conversion of chlorine water into HCl and hypochlorous acid. Next, give reason for decolorizing action of the chlorine. Then you should tell that whatever HOCl is there, it can be converted into HCl and nascent oxygen. and this nascent oxygen, it will react with colored molecules plus nascent oxygen, and it will become decolorized or decolored molecules or colorless molecules. Anything is fine. So that's where we have the important property of the chlorine water or chlorine. Okay? Any doubt? This is the important property of the chlorine, decolorizing property, oxidizing property, and losing the color, yellowish green color due to these reactions. Any doubts in this? Shall we move to the next one? Okay. Now this is related to chlorine. Now when I am talking about chlorine, if I talk about preparation of chlorine, one of the method here is by using manganese oxide. When manganese oxide is treated with HCl, now there will be formation of manganese chloride. And chlorine gas is must, because we are talking about preparation of chlorine gas. So manganese oxide with HCl, manganese chloride and chlorine. Now what should be the another product? Oxygen and hydrogen we have not written on the right hand side. What should be another product? It should be water. Another product should be water. So that's where we have to balance the equation, right? So now manganese fine. Now when it comes to oxygen, there it is 1. I will make it for time being, I will make it as 2. Now 2 2s are 4, so I will make it as 4. I think it is balanced. So that's where we have the reaction. Laboratory preparation of chlorine gas. That is nothing but laboratory preparation of chlorine gas. That is by using manganese oxide and HCl. Now please remember, same thing, same reaction if you change the content. Now instead of using, I don't have HCl in my lab, what to do? Then MnO2, instead of HCl, we can go with NaCl. Plus sulfuric acid. All the product will be same, but along with that one salt will be formed. That means MnCl2 plus Cl2 plus water, but along with that there will be formation of sodium bisulfate. So HCl can be replaced by NaCl and H2SO4. HCl, if it is not available, it can be replaced with NaCl and H2SO4. Now only the additional product which will be formed is NaHSO4, that is sodium bisulfate. Sodium sulfate will be formed, but later further it will react with H2SO4 and it will become sodium bisulfate. Fine. Now we have to balance the equation, right? Now how many? Na is 1, manganese, okay, metals are balanced. But if I talk about oxygen, okay, before that we'll go with hydrogen. There it is 3, here it is 2. Okay, so we have to balance it. So for time being, I will make it as 4 NaCl, because Cl2, Cl2. So I will make it as 4 NaCl. Since it has become 4 NaCl, here it will become 4 NHSO4. Got my point? Now, since there it will become 4, sulfur became 4, so I will make it as 4 H2SO4. Now in that, okay, 2 H2SO4. I will make it as 2 H2SO4. So now I can see 2 2s are 4, 4, 2, 6. Okay, no, it's not getting balanced. So that means 4 NaCl if I make, it's of no use. Okay, you can also balance the equation. You can also balance the equation. So that's where we have the H2SO4. Now what I did was, since it was 4 chlorine, I made it as 4 NaCl. But if I made it as 4 NaCl, it's not getting balanced with respect to hydrogen, because here it will become 4 and 2.
So 4 H2SO4, 4 NaCl.
1 minute. Okay, oxygen, hydrogen you can add it there, no? So 4 NaCl, then here also I will make it as 4 H2SO4, 4 is 8. So here I will make it as 2. Now see, now I think it's balanced, na? Whether it is balanced with 4 NaCl only it will balance. Whether it will balance, fine. So that's where we have the utilization of different reagent. We have utilized different reagent. Next method is by treating potassium permanganate. By treating potassium permanganate with respect to. Okay. So when it comes to potassium permanganate, can you tell me what should be there to give rise to chlorine? Naturally, it should be HCl. It should be HCl. Now, positive, negative, that's where KCl. Positive, negative, that's where MnCl2. Right? So, K plus Cl, KCl, Mn plus, that is Mn plus 2 and Cl minus, therefore MnCl2, and one of the products should be chlorine. What should be another product? What should be another product? It should be water. It should be water. Now once again we have to balance it, right? So 2, 2, 1, 5. So total 5 is there. But if I make it 5 here, it will not be balanced with respect to hydrogen. So we have to use a different strategy. Okay. So in that case, so I will make it as what I'm going to put here. So I'll make it as 6. Now 6 HCl is there. Oh, I think it's balanced, no? So here I should make it as 3. So 3. Okay, oxygen will not get balanced. So in this case, oxygen will not get balanced. So we have to disturb the metal, no other option. Because if I make it as 6, so here it will become 3 water, that means 3 oxygen. But on the left hand side we have the 4 oxygen. So therefore, no other way, I have to disturb metals. No other way for me. Fine? So if that is the case, next number I will go, that is 2 KMnO4. So here it will become 2 and here also it will become 2. Now we will see. So now 6 HCl for time, don't write anything. 6 HCl I am not really anything. First I will balance the oxygen. So 8. I think it will be done. 16 HCl because hydrogen became 16, so here 16 HCl. Now 2 so here I should make it as 5Cl2. Correct? Whether it is balanced, so 2 to the 4 plus 2, 6, 10. Oh, 16 HCl. Fine, it is balanced. So these are some of the methods for the laboratory preparation of HCl. All of you have understood? So this is with respect to laboratory preparation of HCl. Any doubt in this? Any doubt? Fine. So that's where we have the reaction. Okay? Fine. So in that case, we will move to the chemical properties. So one of the property of chlorine we have discussed, that is, it's a very good bleaching agent. It's a very good bleaching agent. Why I am calling it as a bleaching agent? Because it can decolorize. It has the property of decolorizing the molecule. That's why it is a bleaching agent. Why it is a bleaching agent? Because it's going to produce hypochlorous acid, which can release nascent oxygen, which can react with coloring molecule and which will become colorless. So that's where bleaching action of chlorine. Now with respect to other chemical reaction, which I will mention it as important. Okay, so with respect to other reactions, for example, I have ammonia. Reaction with ammonia, important. So reaction with respect to ammonia, it is important. So in the presence of chlorine gas, so we have two types of reaction. In one case, it will be ammonium chloride and nitrogen. Right? Same way, ammonia with chlorine, it will form NCl3 plus HCl. So two types of reactions are there with respect to chlorine and ammonia. So two types of reaction. So naturally, both the reactions should be done under different conditions. See, for example, first one we will balance it. So here it is 2 chlorine. So time being I will make it as 2. So there it is 2 2s are 4. 4 nitrogen. So I will make it as 4. Fine. So 3 2s are 6. 4 2s are 8. No, it will not work out because 4 3 12. Here it is only 4 2s are 8. So hydrogen is not getting balanced. Fine. So I will go to the next number. So even number only I should go. I will go with the even number. So next one is 6. So that means here also I should make it as 4 because 4 nitrogen plus 2, 6 nitrogen. So 6 3 18, 4 4 16. Okay. Ammonium chloride. So 4 4 16. Here it is 16. So that means I have to change. You can also try it out. So 2 will also not work. Okay, done. It is balanced. Yes. So first I tried with nitrogen. Okay, I will tell. So that's where I did a mistake because nitrogen comes 3 times. So instead of that I should have gone for chlorine. Chlorine comes only 2 times. Right? So therefore, that's what with respect to chlorine I started. Now this equation is balanced. So can you do it for second equation? Okay. Now, one nitrogen. So here it should be 3 HCl. So that means 3, so it is easy. So 3 chlorine. Okay. So this is where we have the equation. Nitrogen trichloride. Please remember, nitrogen trichloride is explosive. Nitrogen trichloride is a explosive. One mark question you can expect. Name the explosive product which will be formed when ammonia is treated with chlorine. Then it should be nitrogen trichloride. Fine. So that's where we have the two equations. Now can you tell me what is that difference between these two? Can you tell me what is that difference between these two? Both are reaction of chlorine gas with ammonia, no doubt. But in one case it is forming ammonium chloride and nitrogen gas. In another case it is forming explosive product nitrogen trichloride and HCl. Right? So what is that difference? First. What is that difference? So difference here is, here we have the high concentration of ammonia. But in the next case we have low concentration of ammonia or high concentration of chlorine. Sir, should everybody sir? Illu 6 ide, illu 6 ide. Or here also 3 molecules, here also 3 more. How it's high? No, I am talking about compared to ammonia. Right? So therefore I told it is with high concentration of ammonia. So this is with low concentration of ammonia. Or you can tell that this is with high concentration of ammonia, this is with high concentration of chlorine. Anything is fine. So that's where we will be having two different reactions based on the concentration of ammonia and chlorine. It is a bit important. And one of the product, nitrogen trichloride, is explosive in nature. Okay? So you should remember this. So this is one important reaction. Same way we have another very important reaction. Another one is very important reaction, that is reaction of chlorine with sodium hydroxide. Reaction of chlorine with sodium hydroxide. Now one of the product will be NaCl. One of the product will be NaCl. Another product, you should tell me the name. What is that? NaOCl. What should be the name of this product? NaOCl. NaOCl, sodium hypochlorite. Right? Sodium hypochlorite. So that's where NaOCl. So Jahnavi, that one I will come. Next one. Okay na? Sodium hypochlorite. Plus, what should be another product which we have not written on the right hand side? That is H2O. That is H2O. Fine? So we have to balance the equation, right? So before that, I will write another reaction. Sodium hydroxide with chlorine. In another reaction, it will form NaCl, and someone had written, that is NaOCl3 plus H2O, chlorate. So this is chlorate, this is chloride, hypochlorite, this is chlorate, not only chloride, sorry, hypochlorite. And this is chlorate, sodium chlorate. Sodium chlorate. Sodium hypochlorite. Okay, so these are the products. That's where they differ. Rest of the products are same. So rest of the products will be same. We have to balance it, right? So first we will start with sodium. So time being, I will make it as 2. So in that case, chlorine is 2, oxygen became 2. Okay, it's balanced. Student friendly equation. Only 2 NaOH you should make. So here for time being I will make it as 2. Now what will happen? Cl2. Okay, there it is. I will make it as 2. Now hydrogen, oxygen. Oxygen is 2. So okay, fine. It's balanced, right? Whether it is balanced, it is balanced. Now here it will be under cold condition. It will be under cold condition. Cold and dilute NaOH. Very important it is reaction. Cold and dilute NaOH. This is hot and concentrated. This is hot and concentrated NaOH. Now the question can be, name the product formed or write the reaction for chlorine with respect to hot and concentrated NaOH. Then you should write this one. Or if they ask, write the reaction of chlorine gas with sodium hydroxide under cold condition, then you should talk about this reaction. Fine? So that's where they differs with respect to sodium hypochlorite and sodium chlorate. So that's where they differ from each other. Fine? Any doubt? This is a very important reaction. Now that's where we have another important property of chlorine which you people have discussed in your first P. Another important reaction which you people have discussed in your first P. That is reaction of lime water. Reaction of lime water with chlorine gas. Reaction of lime water with chlorine gas. What is lime water? That should be answered first, right? What is lime water? That is nothing but calcium hydroxide, slater lime. Right? That's where we have the calcium hydroxide. Oh, Jannavi, very good. Slater lime. That's where we have the calcium hydroxide. When it is treated with chlorine, right? So difference between NaOCl and NaClO3. Okay, fine. So NaOCl, this similar molecule people have discussed as HOCl. When it is HOCl, H plus, here it is Na plus. That's what. This is an oxo acid. This is not an oxo acid because here it can donate H plus. Here it will donate Na plus. So therefore, common thing in these two here is presence of ClO minus, hypochlorite. And it is hypochlorite. So therefore, it is called as hypochlorous acid. So this is sodium hypochlorite. So this is sodium hypochlorite. So now when I am talking about another product, that is NaOCl, NaClO3. NaClO3. That means I am talking about chloride ion. I am talking about chloride ion. Chloride ion, chloride ion. Hypochlorite, hypochlorate. Okay, confirmatory test for chlorine radical. Okay, fine, but we have different other efficient reactions. But when it comes to difference between hypochlorite and chlorate, these are the difference. But both will be having one single negative charge. Both will be having single negative charge. Fine. So because if I talk about oxygen, all the oxygen cannot have the double bond. If that is the case, there is no charge. But chlorine will be very upset because it is left over with lone electron. So due to that, what will happen? So one of the chlorine, it will have the negative lone pair of electron, and chlorine will be having lone pair of electron. So it will take electron from H or sodium, and that's why it will become minus. So chlorate ion. So this is where we have the ClO3 minus. Okay. So whether you got the answer, oxidation state is different. In hypochlorite and in chloride, oxidation state of chlorine is different, definitely, right? So that's where we have the difference. Whether I have given the answer, Prajwal, right? So whether I am clear? So we'll move to the next one. So that is reaction of chlorine gas with calcium hydroxide, right? That is slaked lime. Fine. So in that case, when I am talking about slaked lime, when it is reacted with chlorine, so that's where there will be formation of, this is important reaction. It will lead to the formation of bleaching powder, right? It will lead to the formation of bleaching powder. One is calcium chloride and another one is calcium hypochlorite. So calcium hypochlorite, in that case it should be twice because calcium is 2 plus, hypochlorite is -1. So calcium hypochlorite. So what should be another product? Another product should be water. Another product should be water. So that's where we have the reaction. So we have to balance it, right? So 2 calcium, I will make it as 2. So 2 and 2, 4. So here I will make it as 2. But we have to check. So hydrogen became 4. So I should make it as 4. So what about oxygen? Oh, oxygen is balanced. Okay, this is a balanced equation. Right? So whether I am clear? So now when it comes to bleaching powder, composition of bleaching powder will be calcium hydroxide, means leftover reactant, with calcium chloride, with calcium hypochlorite and water. These are the composition of bleaching powder. These are the composition of bleaching powder. So from where calcium hydroxide came, sir? Calcium hydroxide is left over after this reaction. If any calcium hydroxide is left, and definitely it will be left over. That's where we have the bleaching powder. Fine? All of you have understood? Okay? Any doubts? So this one you can expect for your competitive exam. Composition of bleaching powder. Fine? So we'll move to the next one. Therefore, I have mentioned it as important reaction. Anyway, with respect to cold and concentrated NaOH and with respect to ammonia, those reactions are important. Okay? So this reaction you have already discussed in your first period. So now we will move to the next one. That is oxidizing character. That is with respect to oxidizing character of chlorine. Now sulfur dioxide, in the presence of chlorine, it will oxidize sulfur dioxide to sulfate. It will oxidize sulfur dioxide to sulfate. So SO4 minus 2 plus HCl. Okay, if I want to go with ionic equation, then I should not write H, because on left hand side H is not there. We will see whether otherwise we have to take the help of water. So now Cl minus, so 2Cl minus, so equal, okay, and okay, we have to take the help of water, no other way. So I will make it as HCl1. HCl, since hydrogen is there, I will make H2O here. So now 2, so here also 2, 4, and here it should be 4, and here it should be 5. This is the reaction. Fine? So that's where we have the, okay, we can use H2SO4 only. Why to write SO4 minus 2? We can write it as H2SO4. We will not go with ionic equation at all. Now, so 3H2. So 1 minute. Now 4 oxygen, we have 2. So that I will make it as 2. So if I make it as 2, it will become 4 hydrogens and as 2s. Now I will just balance. Right? Balanced. Sulfur is 1, oxygen is 4, 4, chlorine is 2, hydrogen is 4. Yes, it is balanced. So that's where we have the oxidizing property of chlorine. What is the oxidation state of sulfur here? It will be plus 2,
Plus 1.
plus 4, and here it is plus 6, right? But chlorine, from 0 it is becoming minus 1. So that's where we have the oxidizing character of sulfur, chlorine gas. Okay? So along with that, if I take some of the reactions where if you want to go with further oxidizing character, I will go with your textbook only. Okay, fine. So we have sodium sulfate. Sodium sulfate. Na2SO3 plus chlorine. It will get converted into Na2SO4 sulfate plus HCl. Okay? Since hydrogen came, I have to write here H2O. Okay now? So sodium balanced, sulfur balanced, oxygen balanced, but only thing is here 2HCl if I make is balanced. So that's where once again sodium sulfate, it will get converted into sodium sulfate. Another reaction for oxidizing character of chlorine, which will prove the oxidizing character of chlorine. Fine. Now that's where we have some of the chemical properties of chlorine. Now if you take some of the gas, like we have the phosgene gas, which are toxic. Phosgene gas, which are toxic. So now phosgene, what is the formula? We have already discussed what is the formula for phosgene. COCl2, where we have discussed with respect to haloalkanes and haloarenes. So we have phosgene, tear gas, right? So they are going to make tears to come out of our eyes. Okay, it will be irritating the eyes. So therefore tear gas. So these police, they will be putting all this tear gas to spread the mob, right? So that's where we have the tear gas. Another one. Then we have the mustard gas. Then we have the mustard gas. Mustard gas, they are actually one of the component of warfare agents. During the war, they used to use. We should not use actually. Mustard gas is very toxic. It can react with our DNA. So that's where we have some of the toxic gases which will be produced due to the chlorine. So among that phosgene, that is COCl2, then tear gas and mustard gas. So all of them, they are the example for toxic gaseous molecules from the chlorine, produced from the chlorine. Fine? So all of you have understood? Now we will move to the next one. Next one is HCl. Next one is HCl. Okay? So next one is HCl. Now when it comes to its preparation, one of the common method here is treating sodium chloride with sulfuric acid. This reaction already we have discussed. Where? This reaction already we have discussed. Where? That was with respect to properties of sulfuric acid. Right? So that's where it's going to form HCl plus Na2SO4, which will later get converted into sodium bisulfate. Later get converted into sodium bisulfate. So now here I will make it as 2. So here I will make it as 2. That's where one of the method for the preparation of HCl. Okay? One of the method for the preparation of HCl. Approximately 420 Kelvin. Fine. This reaction why I have written here, because same reaction we have discussed earlier also. Now I will come to important property of HCl, hydrochloric acid. Now I will come to important property of HCl. So if I take HCl, if I use it in combination with nitric acid, HCl with nitric acid in the ratio of 3:1. This ratio is important. Now it is called as aquaresia. Now it is called as aquaresia. So whenever I will be talking about this solution, combination of HCl and HNO3, always I will be remembering one of the incident which took place when I was doing my research. So we had one problem where we had one instrument where one metal wire got stuck. Okay, it was inside the coil where one metal wire got stuck. Now we were worried how to take out that metal wire, because coil means it will be having spring type of structure. So now that's what we were scratching our head. Okay, so now we put that particular whatever coil is there, we dipped that one in HCl, we kept it for 2 days, that metal nothing was happening. Then we changed the acid, we went for sulfuric acid, then we waited for some time, means some days, nothing had happened, but still that metal wire was inside only. Now we were worried how to take out that metal wire. Now one kid who was there, he told this combination. We had in our syllabus, I think in 10th standard or 9th standard it is there. He told, why don't you try with this particular combination? Then okay fine, when we recollected, okay fine, yes, this one solution is there. So when we put that particular coil into this solution, in 2 hours that metal wire got dissolved, which we tried alone acid for 2-3 days, nothing happened. But the same metal wire in 2 hours, it got melted completely, nothing. It came out in pieces, right? So that shows the property of this aquaresia, royal water. So aquaresia means royal water. Why it is called as royal water? Because it has the capacity to melt or to react with the gold and platinum. Most of the acids which are not going to react with gold and platinum, but these in the combination, they have the capacity to react with the gold and platinum. See, for example, this is very important for your exam point of view. This also reaction also. So we have gold, HCl, HNO3, whatever combination, H plus will be there, Cl minus will be there, NO3 minus will be there. Just write whatever ions you are going to get. Then on the product, we are going to get oro tetrachloride. That's why we have the AuCl4 minus. Okay. Now another product will be nitric oxide. Another product will be nitric oxide. So another product should be, since H plus is here, so it should be water. It should be water. Now to balance this equation, we will go with the redox method. So Au from 0, it is becoming plus 3. Right? So how many electrons is getting loosed? It is getting losing of 3 electrons. Now nitrate, it is becoming nitric oxide. That means from plus 5, it is becoming plus 2. That means it is gaining 3 electrons. So that means electron wise it is already balanced. So fine, that's where Au plus NO3 minus which will give rise to AuCl4 minus and NO. No need to add anything. You keep these things as it is because with respect to number of electron, they are balanced. Now we will write the rest of the things. H plus Cl minus. And here it should be H2O. Now since there is 2H2O, here it should become 2H plus. Right? So here it is 3. Okay, fine. So we have to change. 2H plus we cannot go because oxygen will not get balanced. So in that case, here it should become 2H2O so that it will, we cannot disturb this. So 2H2O, now oxygen became 3. Now here it will become 4. Right? So 4H plus 2Cl minus. 1 minute. Minus 1, that is minus 2 plus 4. Left over will be minus 2. But here it is minus 1. No, it cannot be done. No, it cannot be done. So it should be, if I make it as 3H plus, now there will be a problem. So I will make it as left side. I want minus 1 should be left over. That's all. My intention is minus 1 should be left over. So, oh fine. Cl4 is there, na? I forgot that only. Fine. So 4Cl minus. Now I think it can be done. So 4H plus. Right. Now it is done. I forgot Cl4 and we forgot to make it as 4Cl minus. Fine. So that's where we have the equation. Very important. So gold with nitrate, it will become oro tetrachloride and nitric oxide, and that's where Cl minus, it will remain as it is, minus 1. Fine. So that's where nitrate is the one which is oxidizing the gold to plus 3. All of you understood? Fine. So this is with respect to the gold. Another important reaction is with respect to platinum. Another important reaction is with respect to platinum. Okay. Now when it comes to platinum, same thing. So H plus Cl minus NO3 minus. Right? Now it will be platinum hexachloride. Cl6 minus 2. Platinum hexachloride plus NO, nitric oxide, plus H2 plus H2. Fine. Now from 0 it is becoming plus 4. From 0 it is becoming plus 4. And when it comes to here, so from plus 5 it is becoming plus 2. So that means there is a losing of 4 electron, and that's where there is a losing of or addition of 3 electron. So not matching, right? So we have to cross multiply. So 3 should come here. So I will make it as 3 platinum, then H plus plus Cl minus. This one should be multiplied by 4. So I will make it as 4 NO3 minus, which will give rise to, so 3 platinum hexachloride plus 4 NO plus water. So whether I am right? So I have multiplied this 4 to this, and I have multiplied these 3 to here. Whether I am right? Oh. So in that case I will remove above equation. This will be the last one, don't worry. Oh, fine. Now we should not disturb platinum meltdown. So we should directly target other elements. So if I take, so I will go with chlorine. So R mood 18. So directly I can make it as 18 Cl minus. 18 Cl minus. Right? Now when I have written 18Cl minus, how many negative charges are there? 18 plus 4. It will be 22, right? 22 minus plus 1 is there 1. So therefore it will become 21 negative charge. So here it is only minus 6 negative charge. Minus 6 negative charge. So I should be making it as minus 6 on the left hand side also. I should make minus 6 on the left hand side also. In that case, so 22 minus 6, it will be it will be 16. So straight away I will make it as 16H plus. So here I will make it as 8. I think it is balanced. It should be balanced. Correct? It is balanced now. Because left hand side total charge left over will be 18 minus 6. And right hand side also it is minus 6. It is balanced equation. So that's where we have the reaction. Any doubt? That's where we have important concept, that is aquaresia. That's where we have the important concept with regard to aquaresia. Please remember these reactions. Okay? And more than reaction, you should remember that ratio. Okay? Aquaresia is nothing but royal water. Any doubts? And don't make this ratio reverse. It will be 0 marks for you. Okay? So HCl is in 3 and HNO3 is in 1. In that combination, it will work as aquaresia. Any doubts? Okay, today also I was not able to finish it off. So last one, group 18 elements left over. Tomorrow definitely it will be done. No doubt. Tomorrow it will be over. Okay? So if you don't have any doubt, any doubts? So whatever we have discussed, ammonia with chlorine, sodium hydroxide with chlorine and bleaching action of chlorine, then aquaresia and the reactions, they are all important concepts what we have discussed today. Okay? So if you don't have any doubt, I will stop here. Thank you very much. Take care. Bye. Okay na?